Hello friends, welcome back to Let's Do Mathematics. Today we have a problem of JEE vectors pyq series. So we are going to solve this problem. So we have given two vectors and a third vector C has been defined by linear combination of these two vectors. Now we have given projection of C on the vector A plus B is 3 root 2. Then the minimum value of this C vector A cross B dot C we have to find out. Now A plus B is equal to, first of all, A plus B is equal to 3i cap plus 3j cap, and modulus of this vector A plus B is equal to under root 3a square plus 3a square. So this is equal to 3 root 2. Now also A dot B is equal to, here A dot B is equal to 2 times 1 plus 1 times 2 plus 1 times minus 1, and this is equal to 3. And also, so this is equal to B dot A, and modulus of A square and modulus of B square is equal to 2a square plus 1 square plus negative 1 square, that is 6. So these calculation are required in our our next steps. So we have to find out this. So now, since C is a linear combinations of vectors B and vectors A, therefore A cross B is perpendicular to vector C. This implies that A cross B dot C must be 0. So also, since given that C projection of vector C along A plus B is equal to 3 root 2, so by the formula C dot A plus B over modulus of A plus B is equal to 3 root 2, and this implies that vector C dot A plus B over 3 root 2 is equal to 3 root 2, as we have calculated modulus of A plus B is equal to 3 root 2. So we have C dot A plus vector A plus B is equal to 3 root 2 times 3 root 2, that is 18. So now we have given C is equal to alpha times A vector A plus beta times vector B, and this is equal to dot vector A plus vector B, and this is equal to 18. Now we can write this by distributive property, alpha times vector A dot A plus B, and this is beta times vector B dot A plus B, and this is equal to 18. Now we can, using property, we can write this as alpha times modulus of A square plus alpha times A dot B, and this is beta times A dot B plus beta times mod of B square is equal to 18. So this is equal to 6, and this is equal to 3 times A plus 3 times B beta plus this is 3 times alpha, and this is 3 times, so this is equal to 6 is equal to 18. Now we have 9 times alpha plus beta is equal to 18. So this implies that alpha plus beta is equal to 2, and therefore beta is equal to 2 minus alpha. Now we have to minimize. So our objective function is our given function, so we have to minimize C minus A vector A cross B dot vector C. So this is equal to C dot C minus A cross B dot vector C. So this quantity is 0, as we have discussed earlier. So this is equal to C dot C minus 0. So we have to find out this function. So C dot C is equal to alpha times A vector plus beta times B vector dot alpha times A vector plus beta times B vector. This is beta. So this is beta. Now we can write this as by distributive property. This is alpha times A dot alpha times A vector plus beta times vector B, and this is beta times vector B dot alpha times vector A plus beta times vector B. So this is equal to alpha square modulus of A square plus alpha times beta A dot B, and this is beta times alpha beta times B dot A plus this is equal to beta square modulus of B square. So putting the values of this alpha modulus of A dot B and modulus of A, we have this is 6 alpha square plus 2 alpha beta times 3 plus beta square times 6. So we have 6 times alpha square plus alpha beta. So this is alpha beta plus beta square. Now we have to minimize this function. So alpha, so write this alpha times beta. Now we have to minimize this function. So first of all, we have obtained beta is equal to 2 minus alpha. So putting beta is equal to 2 minus alpha, we have alpha times 2 minus alpha, and this is 2 minus alpha square. So this is equal to 6 times alpha square plus 2 alpha minus alpha square plus 4 plus alpha square minus 4 alpha. So this is equal to alpha square gets out to be cancelled. 6, this is alpha square minus 2 alpha, this is alpha square minus 2 alpha plus 4. So taking this as f alpha, so we have to minimize this function. So first of all, differentiate this. So f dash alpha is equals to 2 alpha minus 2, and this is equal to 0. So alpha is equal to 1 is critical point. Now alpha, now we have, if we differentiate this f dash alpha, so f double dash alpha is equals to 12, and this is greater than 0. So at alpha is equal to 1, f alpha attains minimum. Therefore minimum value of 6 times alpha square plus alpha beta plus beta square is 6 times 1 square, and beta is equal to, if alpha is equal to 1, then beta is equal to 2 minus alpha, that is 2 minus 1, that is 1. So this is 1 times 1, and this is 1 square. So 6 times 1 plus 1 plus 1, that is 6 times 3 is equal to 18. So 18 is the minimum value, required minimum value of this quantity. So answer is 18. Thus we have solved the problem. Thank you for watching this video. I hope you have understood this solution. Let's see you in the next video. Thank you.